So we're back and we're going to be solving radical equations, this time algebraically. We had a previous lesson, not sure how recent, but we did solve by graphing, sometimes on the calculator, sometimes by hand, and this time we're going to be solving them strictly algebraically. You can still use the calculator to check. So first thing I'm going to do is to use my gut instinct. If I want to get rid of a square root, I would square. And because it's an equation, we're going to square both sides. So squaring the square root is just going to give you an x, and then equals 25. And it's as easy as that. So some of them are really, really basic. So let's look at this next one. I don't want to square yet, because I really don't like squaring things that have more than one term. So what if we do a little isolation first? What if I added 2? So now we have the square root of v equals 10, and now I can square both sides. And we end up with v equals 100. Now, I kind of ignored part of the instructions here. It says you should be checking your solution for extraneous answers, and we should be, especially with these being so easy. So if I was going to go back to number 1 and plug in a 25, if I took the square root of 25, I would get a 5. So that's as easy as checking is. You don't even have to show it. So back to this original one, if I were to plug in a 100 right here, the square root of 100 is 10. So negative 2 plus 10, yes, that is 8. So there, it's nice to leave a problem knowing you got it right. Okay, number 3, we're ready to square both sides to get rid of the square root symbol. On the left side, the square root and square just cancel, and you end up with a 3n plus 4. On the right side, you do have to square the 4, and you get a 16. So now I have a real basic linear equation that I can solve through just a couple of steps. I'm going to subtract 4 from both sides. Isn't math beautiful how it builds, and all of a sudden these problems that a few weeks ago were giving you a little trouble are no longer going to give you any trouble. 16 minus 4 is 12. And then finally, last step, divide both sides by 3. So we end up with a solution of n equals 4. And I should go back and plug it in and check it. 3 times 4 is 12. 12 plus 4 is 16. If you were to take the square root of 16, you'd get 4. Alright, this one looks scary, but look what happens when you decide to square the left side of the equation. That forces you to square the right side of the equation. And then they just kind of cancel each other, right? So the square and the square root, so you end up with negative 3 minus 2x. And then same cancellation over here, you end up with 2 minus x. So now you do have a couple of steps on this equation to solve, but we're going to be able to handle this one. I'm going to add 2x over to the right side. And then I'll subtract 2 to the left side. And I end up with negative 5 equals x. Yes, it's backwards, but it still works. It's a little dangerous, Abruzzo. I should have checked before I boxed it in. If we were to plug in a negative 5 right here, we'd get the square root of negative 3, and then negative 2 times negative 5 is a plus 10. So we end up with the square root of 7. On the right side over here, if you plug in a negative 5, you get square root of 2, and then minus negative 5 will be plus 5. So once again, you get square root of 7. So that time I did show the check scribbly on my paper, but it's not hard to check these, and it is a rare occasion in math when you leave a question and you know you got it right. Okay, this next one looks really innocuous, but it's a little more challenging than people give it credit for. So we know we're going to square both sides to knock out the square root on the left side. So we have negative 30 plus 11b. And then if you square the b, now you have a b squared. Oh my goodness. Ladies and gentlemen, you have a quadratic. So now you get to choose one of your methods for solving a quadratic. You've got factoring. You've got completing the square, which is kind of going along with square rooting, and you've got quadratic formula. Quadratic formula always works. Factoring is probably your favorite, believe it or not. And completing the square is my favorite, but it doesn't always work nicely. So choose. And most of you, I know this sounds strange to say, but most of you will pick factoring. And on today's lesson, that would be a wise choice, because any quadratic I give you today on today's lesson, it's going to be factorable if it's a quadratic. So because we like factoring, it needs to say equals 0 on one side. I'm going to go ahead and move everything to the right side. I'm going to add the 30, and I'm going to subtract the 11b. All right. Woo, ugly. Okay, so 0 equals b squared minus 11b plus 30. So now I go through all my factoring techniques. This is a guess and check trinomial. I need my first numbers to multiply to give me b squared, so of course those are b times b. I need the last numbers in the binomials to multiply to 30, but keep in mind I need the arches to add up to negative 11. So what if we had a negative 5 and a negative 6? That would do the trick, right? So now we need to solve. Don't forget you're solving this. So that means b minus 5 has to be set equal to 0, and b minus 6 has to be set equal to 0. And you get two answers. Now, you must check, especially when there's a quadratic, because quadratics get everybody nervous. Sometimes you have what's called an extraneous solution. It shows up, but when you plug it back in, it just doesn't work. The check doesn't have to be shown, but it might be smart. So my check, I'm going to kind of do over here. So if I plug in actually I'm going to do it on both sides because I'm going to run out of room. If I plug in a 5, on the left side I get the square root of negative 30, and then 11 times 5 is plus 55. And on the right side, I would get 5. So this is square root of 25, which is 5, check. So 5 works. I'm going to box it in. But what about 6? Because one could work, neither could work, both could work. So they're all options, I guess is what I'm saying. So you got the square root of negative 30, 11 times 6 is 66. And then if I plug in a 6 over here, does it equal 6? So this is 36. Does the square root of 36 equal 6? Yes. So this was a case where we ended up with a quadratic. I got two answers, and they're both good. I bet you think you know what's going to happen here, huh? All right, so we are ready to square both sides. And this is the most frequently messed up question, because on the left side here, when you do v minus 2 squared, you're actually foiling that out, right? It's v minus 2 times another v minus 2. On the right side, that's an easy fix. The square root and the square will just cancel each other out. But I do need to distribute over here. So, get a little distribution going. We end up with v squared. And then minus 2v with another minus 2v. And then negative 2 times negative 2 is plus 4. So, ladies and gentlemen, once again, we have a quadratic. So I got to choose my favorite method for solving a quadratic. Believe it or not, it's going to be factoring for pretty much all of you. Those of you who really love the other methods, go for it, but I'm going to go with factoring. So because I want to factor, I need to bring everything over here to the one side of the equation. I'm going to keep my quadratic term positive. So I'm going to subtract 4v over here. I'm also going to add the 11 over here. Alright, I'm doing a math teacher trick right now. Sometimes this is dangerous, but you see all these like terms? I'm just going to smush them together. Like rather than simplifying and then moving terms around, this is another option. So v squared drops down. Negative 2, negative 2, negative 4 would be a negative 8v. And then of course I'm going to combine those to a 15. Alright, it's time to solve the quadratic. I am going to factor. So multiplies to v squared, obviously that's v and b. Now I need my end numbers to multiply to 15, but if you could also keep in mind that you need your arches to add up to negative 8. So what if we used a negative 5 and a negative 3? That would work, right? So next step is solving. I know it's tempting to skip and just be like, here's my answers. But these are your notes, so it doesn't really help you any if you skip steps. So set this and this equal to 0. So we have v equals 5 and v equals 3. But now I need to check. So the original problem, and you do have to go all the way back up to the original problem. It was v minus 2. So I'm going to kind of check them side by side here. It was v minus 2, so 5 minus 2 equals square root of, hello, where'd you go? 4v minus 11. So 4 times v would be 20 minus 11. So this is 3 equals the square root of 9, which is correct. All right, and then we're checking a v equals 3. So that would be 3 minus 2. I forgot. Was it 4 times v? Yeah. So 4 times this would be 12 minus 11. Oh, interesting. 1 does equal the square root of 1. So this is another case where both answers worked. So I don't have an example on here where one solution doesn't work and we call it extraneous. That was my bad. In hindsight, I would like to create one that has that. I know we'll do one like as our warm-ups as we work together during either synchronous learning or during our class time if we're blessed enough to have class time. But I will show you what it looks like when you algebraically. It looks like this. You get a quadratic and you go to check them, and one works and one doesn't. So just keep that in mind as you progress through your homework and as we work on things like on a test or a quiz. You will have examples coming up where you get 2 answers, but they either one or both don't work. So we would cross them off and say that they're extraneous. My bad. I should have given you an example of that. I promise we'll do one, okay? All right, good luck, everybody.